Before the days of GPSs, when the only way you could find your position at sea, away when you're well away from land, was by using the sun, the stars and the planets. So there's three things required for finding your position, that is since the 18th century. So I'm dealing with the 18th century till about 1980 probably, when GPS came in, somewhere around there. So the first thing that you needed was a chronometer. A chronometer is defined as a timepiece that is precise enough and accurate enough to be used to determine longitude by measuring time at a known fixed location, i.e. Greenwich in London. It was invented by John Harrison in 1764, a carpenter in Yorkshire. So latitude is distance north or south of the equator. That can be accurately accessed by determining the maximum altitude of the sun at noon. In 1714, the British government offered a prize of £20,000, which is a massive amount of money in those days, for someone that could invent a chronometer. Obviously, the clocks that worked by pendulums were no use on a rolling ship at sea. In 1779, Cook used the clock that Harrison invented to give positions accurate to within 8 miles, thus proving that it worked. The government's position was that they wanted position within 30 miles. Wow. So Harrison was actually given £14,000 for his work. So basically the operation of a ship is that around 9 o'clock in the morning, the third mate will take a sextant angle of the sun. That's a sextant angle of the sun against the horizon. That will give him a position line, only just one position line. Then at noon, I'm talking about noon sun time, that's when the sun is directly overhead, maximum altitude. You take a second sextant altitude, and that will give a second position line. You then run the first position line up by dead reckoning to the second one, and that gives you an approximate position. So this is a sextant. A sextant is a doubly reflecting navigation instrument that measures angular distance between two available objects, i.e. a star, planet or sun, and a visible horizon. It was invented around 1731 by John Hadley and Thomas Godfrey. Older instruments were the astrolabe from 1295 and the backstaff, but both these instruments were nowhere near as practical or accurate to use as the sextant. So to operate the sextant, it has filters here for sunlight, because you cannot look directly at the sun, of course. So you make it go to, you take it to 0 and return everything to 0. Then you look up at the object. I'll find an object in this room, and that, if I can see correctly, that's the and get it into focus, that is the air conditioner up there. Then you take it down. The air conditioner is now coming down, and you take it down to the horizon, and with this instrument you can see both the air conditioner and the horizon at the same time. The next stage you do, you start to count 1, 2, 3, 4 as you rush into the chart room to read the chronometer, because after all, if you get the seconds wrong, your position will be wrong. And then you write those down. The calculation for longitude for latitude, sorry, that's either north or south of the equator, is fairly easy, but the longitude calculation is more complex, as basically it is solving spherical triangles. It is not simple maths at all, it's quite complex maths. Now, aircraft used to have sextants, of course, and they had an artificial horizon on them. In other words, a bubble that would give you an artificial horizon, because they couldn't see the horizon in the middle of the night. Now, today in Perth, this is the 12th of the 7th, 19. I hope you don't mind me reading this information. Sunrise was at 7:16, and the bearing of the sun was 64 degrees. That is east-northeast. Sunset 17:28, bearing 276. Now, solar noon, the sun doesn't go overhead at the same time every day. It varies. So, for example, in Perth, today the sun was overhead at 12:22 p.m. That is 22 minutes of daylight saving. Earlier in the month, or last month, it was only 12 minutes after noon local time, that is. Nautical twilight, which is the only time when you can use the sextant to take the stars or the planets, that was between 6:19 and 6:49 this morning, and between 17:54 and 18:25 hours this afternoon. So it gives you about 30 minutes to take sights. This sextant was manufactured, it's a Zenith sextant, manufactured in London by Heath and Company, January the 3rd, 1940. So it may have been on some very interesting adventures. And I bought it on the 26th of the 6th, 1962, when we sailed out of London, and there was I looking at all those beautiful houses and thinking how nice it would be to be in one instead of on a ruddy ship going to South Africa. The third mate failed to join the ship, so I was promoted third mate, and that's how I got this sextant from the master of the Richmond Castle. The Richmond Castle was the only ship I've ever sailed on without a gyro compass. So that is a copy of the Nautical Almanac 1968, produced jointly by the British and American governments. That is a star chart used to, if you can set it so that it will show you exactly where the stars are. That's American, by the way. And that is the picture of the Richmond Castle there, that book there. And that is the company's advertising brochures for getting people to join up as a cadet.